Confidence intervals for population means when this population standard deviation is unknown. It's a critical component of statistics. When the population standard deviation is unknown, we use the sample standard deviation S sub x to estimate what the population standard deviation would be. In place of z-scores, we must use the following to standardize the values. We must use what is called a t critical value. So we're moving away from z critical values and now talking about t critical values. The use of the value of the sample standard deviation introduces extra variability. Because we are unsure of how the population varies, we have to account for the potential margins of errors in the sample standard deviation. Therefore, the distribution of t values have more variability than a standard normal curve would. There are some important properties of t distributions that need to be known. The first is that the t distribution corresponding to any particular number of degrees of freedom, more degrees of freedom in a bit, is bell-shaped and centered at 0. So this is actually very similar to the z standard normal z curve. Each t distribution, however, is more spread out than the standard normal distribution. So what this is showing here is that the t curve is a little bit more spread out than the z curve. Again, we're trying to account for that variability that we lose when we do not know what the population standard deviation is. So continuing with the properties of the t distributions, as the number of degrees of freedom increases, the spread of the corresponding t distribution decreases. So first, the degrees of freedom is how much statistics are free to vary. How much statistics are free to vary. And what this is saying is that because statistics are vary from sample to sample, we need to now account for that now that we truly don't know much about the population. And that is actually why the sample size has the biggest impact on the degrees of freedom. The degrees of freedom is the sample size minus 1. So the higher the sample size, the less variability, the less freedom statistics have to vary because we are itching closer and closer with a larger sample size. So as the sample size increases, degrees of freedom increases, which means that the freedom that variables have tends to go down. As the number of degrees of freedom increases, the corresponding sequence of t-distribution approaches the standard normal curve. So what this is talking about is that as the degrees of freedom increases, which means as the sample size increases, the curve starts to look similar to a z-curve. It starts to look more and more like a z-curve. So typically speaking, we actually use the t-curve for small samples because if we have a large sample, it would look fairly close to what a z-curve would look like. Therefore, as the sample size increases, the degrees of freedom increases, so the t critical value starts to look very similar to the z critical value. Let's go through an example together. A publisher wants to estimate the mean length of time all adults spend reading newspapers. To determine this estimate, the publisher takes a random sample of 15 people and obtains the following results. They want us to assume that the population of times is normally distributed. So first, we need to find the point estimate of the population mean. So we need to find a statistic that estimates how much the population mean would equal. By now, we should all know what this statistic is. For this problem, it will be the sample mean. We need to figure out what the sample mean equals. So we can put the list into our calculators, which I've already done, and find what the mean of these numbers are. So if you go to stat, one variable statistics, and input the list which was list 1 for us, make sure there is nothing in your frequency list because that is only used for probability. and calculate, then we now know what the sample mean is, which is 9.07. We will also use this to find the sample standard deviation, but we will do that in just a second. So the sample mean is 9.07 minutes. So the point estimate is saying that this sample predicts that the number of minutes an adult spends reading the newspaper is 9.07 minutes. However, there could be some margin of error, so we would be better off using a confidence interval for our prediction. So Part B asks to construct a 95% confidence interval for the mean population length reading time and interpret it. So before we perform a confidence interval, we always have to check the conditions. So the conditions for a t distribution is the same for the conditions for a z distribution. The general formula for a confidence interval for a population mean based on a sample size of n can be used when the sample mean is from a random sample, the population distribution is normal, or the sample size n is large, or the population standard deviation is unknown. Also, we must always remember that the sample size needs to be less than 10% of the population. And that's to just avoid replacement errors. So let's check the conditions in this problem to see if it's true. One is does the sample come from, does the statistic come from a random sample? The answer to that is yes. The sample is in fact random, as the problem states that. So we don't even have to make that assumption. Number two, is the sample large? Well, it's not large enough. It's only 15 people. However, the problem does say that the population of times is normally distributed, meaning the population distribution is normal. So the population distribution of times is normal. It is very important that you write down the conditions before you complete a confidence interval. And the last thing, we can assume that 15 people is less than 10% of all people who read a newspaper. It's less than 10% of the population. So we can now perform a confidence interval. So in order to calculate the confidence interval, we need to have our formula. Okay, so we need a statistic, which we found is the sample mean. And now we need to figure out what kind of critical value we can use. Since we do not know the population standard deviation, we need more variability. So we're actually going to use the t critical value and not the z critical value. And then finally, we need the sample standard deviation and the sample size. So we know what the statistic is. It's 9.07. And we also know what the sample size is. It's 15. In order to find the standard deviation, we have to use the standard deviation from one variable statistics, which they were able to find for us. We didn't have to actually do the calculation. And you never have to do the calculation. Please use your calculators. So the standard deviation of the sample is 1.58. Remember to use SX. And finally, the t critical value. The t critical value. To find the t critical value, we have to use our t chart. Okay, so we're introducing a new chart to this unit as well. The t chart is actually much simpler to read than the z chart, because the z chart gives you the confidence levels on the bottom, and it also gives you the degrees of freedom to the left of the column. So first, we need to find out what our degrees of freedom is, which in this problem, it was our sample size, which was 15 minus 1 equals 14. So when you're completing these problems, make sure you write down what the degrees of freedom is. So degrees of freedom is equal to 15 minus 1, which is 14. Now that we know our degrees of freedom, we're able to find our critical value, which is equal to 2.145. 2.145 would have a 95% confidence level. And it's as simple as that. So, as you see, the critical value is in fact larger than the z critical value of 1.96. So that gives us a little bit more variability, a little bit more range here. Okay? So, we have everything we need in order to calculate the confidence interval. We calculate it, and we would end up with 8.14 and 9.94. So the final step here is to interpret it. So the interpretation would be, we are 95% confident that the mean time an adult reads a newspaper is between 8.14 and 9.94 minutes. We can always use our calculators to check all of our statistics and intervals to see if they are accurate. To do so, we will want to go to statistics, over the test, and then we want to click on number 8 for t interval. Remember, we're doing t intervals now. So you can do it in one of two ways. You can either type the numbers into your list and then put the list in the calculator in the confidence level, or you can input the statistics into the calculator as well. Since we did a one variable stats, the calculator actually put the list into the stats into it for us already. So in either case, we will be able to calculate whether or not our confidence interval was accurate. So it was pretty accurate, 8.19 and 9.94. So the important thing to remember here is that using a t-distribution is only effective for small samples and when the population standard deviation is unknown.